Hello Snowflake engineers and welcome to section introduction for event tables. We will start off with what is an event table and also try to understand what it is not. There are some general misunderstandings about the event table, and when we complete this topic, those misunderstandings will be fixed. Next, we will discuss event types supported by event tables. There are two event types that are supported by event tables in Snowflake, and we will learn the differences between them. We will also learn how to enable event logging and, very importantly, how to turn it off when it is not needed. Log level or trace level needs to be set to enable event logging. We will learn how to set log level or trace level and the differences between them. We will then jump into an interesting lab exercise where we will create event tables. In addition to creating event tables, we will also create a stored procedure which will generate the events and log them to the event table. At the end of this lab exercise, you should have a really good idea of how events are generated and how we log them. Before we use event tables, it may make sense to understand what its limitations are so that we do not use them in areas that we should not use them. So we will try and understand the limitations of event tables. This will be followed by cost of logging events. Logging events consume credits, and hence we should understand the costs associated with logging events so that we can make good decisions regarding credit consumption with related to logging events. And finally, a summary which will cover a high-level review of all the event table topics. What is an event table? An event table is a Snowflake table type that is designed to capture error messages or information messages generated either by Snowflake automatically or generated by Snowflake provided logging functions used by a Snowflake data engineer in their code. The use of event table eliminates the need to set up a custom logging table that we design and writing code to log messages in that table. Messages with event tables can only be captured when generated from a UDF, a user-defined table function, or stored procedure. It cannot be done from anywhere else. So, if let us say you drop the employees table from Snowside, there is going to be no log message generated regarding the dropping of the employees table. And the reason for this is because this was done outside a stored procedure. If this was done inside a stored procedure, then we have the option to log it. Snowflake supports two event types, log events and trace events. Let's try to understand them. Log events or log entries are generated by Snowflake provided logging functions used by a Snowflake data engineer in their code and can be used to determine what happened during the processing of the code. So if you dropped a table from inside a stored proc, you could create a log event to capture that. You can also create log events to capture specific data situations like poor data quality or a missing primary key on a table or a business scenario like low inventory. So you can generate log events based on your data or business requirements. On the other hand, a trace event is the process of logging the invocation of your code like stored procedure, UDF, or user-defined table function. Snowflake creates a record of the invocation, and such a record is called a trace event and is done automatically by Snowflake. Now, if you're wondering what the word invocation means, it simply means the process of calling the stored procedure with the call word. Event logging costs credits and storage, and hence you need to enable it to be able to capture log events and trace events. Let's try and understand what log level is. Logging needs to be enabled to log events. By default, log level, which controls if logging is enabled, is set to off. Logging is enabled by setting log level to any value other than off. Let's check what values log level can take. As you can see, there are several values that log level can take starting from trace to fatal. So the next obvious question is, why do we have so many log levels? The reason why we have so many log levels is because depending on the severity of the issue you want to log, you can choose the log level. So inside your stored procedure, you determine that your production table is empty and truncated by someone. It is a very serious issue and you would want to generate a fatal log event to reflect the seriousness of the issue. However, if you are just trying to debug the program, you would want to log the event as a debug which is far less severe than fatal. We use system$log to log a message in the event table and provide the parameters to indicate the severity. You could use trace, debug, info, warn, error, and fatal, which are basically increasing in the level of severity. So as we just said, the lowest level of severity is trace and the highest level of severity is fatal. So what we see is that Snowflake has provided us with a hierarchy of log events starting from trace to fatal. Log entries are generated by data engineer code, and hence they need to choose at what level to log a given error. Logging the error in the event table does not automatically generate any other action. So you need to remember that. We need to actually go to the event table, look at the error message logged, and take corrective action if we want to. If you set the log level to be equal to info, all log events that are less severe will not get logged to the events table, which in this case is equal to trace and debug. So only those events that are equal to or more severe than the log level set will be logged into the events table, which in this case would be warn, error, and fatal, in addition to, of course, info. Trace events are generated and stored inside event tables automatically by Snowflake to record the invocation of code like UDF, user-defined table functions, and stored procedures. In order for trace events to be logged, we need to set up the trace level. The value of the trace level is set to off by default. Trace events can be enabled by setting the trace level to any other value other than off. So the question is, what values can trace level take? So the value that trace level can take are either on event or always. When the trace is set to equal to on event, trace events are logged in the event table if the code generates log events in it and adds them to the events table. If the code does not generate any log event, then no trace event will be generated. When trace level is set to always, trace events will be logged in the event table every time the code is called or invoked, irrespective of if there are log events being generated by the code. If you do set the trace event to equal to always, you will have information on all stored procedures being invoked, irrespective of if it is generating log events or not. Let's jump into a lab exercise in which we will create an event table and generate log and trace events. We will start by creating a database called logging. Inside this database, I will create a schema called event logging. The name of the database and the schema can be anything you like. There is no restriction on the name because we are going to create event tables inside of them. Next, I'm going to go ahead and create an event table called events. As you see, I did not provide any column names. The reason for this is because the structure of the event table is predetermined by Snowflake and we do not have any control over it. We will review the structure of the event table in a bit. Now I'm going to go ahead and create my second event table. So I created two event tables, which shows that I can create more than one event table in an account. I can see these event tables by doing show event tables. While we can create more than one event table, we can have only one active event table for an account. So what we need to do is that we need to make Snowflake aware which event table to use when logging the events. And this can be done by using the alter account statement and setting the event table we want to use. Let me go ahead and run that. When using the alter statement to set the event table, you need to provide the entire path of the table, including the database name and schema name. This is done so that we do not accidentally set the incorrect event table name. Let me go ahead and try to remove the database name and schema name and try to set the event table for the account. As expected, it tells me that the event table events is not fully qualified. So this shows us that we need to provide the fully qualified name in order to set the event table for the account. Now, if you're wondering why Snowflake forces you to use the database name dot schema name, The reason for this is because you could create the event table in any database inside the account, and you could have event tables with the same name across several different databases. So Snowflake is forcing you to provide the database name dot schema name so that there is no confusion or mistake when setting the event table. Time to create some events. In order to generate events, what I have done is that I have written a very simple stored procedure. We will review this stored procedure and try to understand its logic. The procedure is called sp underscore dq underscore employees, where sp stands for stored procedure and dq stands for data quality. And then this procedure is going to run on the employees table, so I used employees. It has an input parameter called message, which is of data type string. So when calling the stored procedure, I will pass in a message which will be used by the stored procedure. I will be using language SQL. I will start off by declaring a few variables, and these variables will be used inside the stored procedure. We will then start with the executable block begin. I use system$log trace program has begun to log information that the program has begun. I could basically write anything I want inside the system$log, like hello world or anything else. The goal of the message is to help me understand what the program is doing and to generate the trace event. It is concatenated with the message variable, which comes in as input parameter when we invoke the procedure. This is followed by our data quality check in SQL, where in the first SQL we will check to see if there are any null department IDs in the employees table. In the second SQL, we are checking to see if there are any null employee IDs in the employees table. And finally, in the third data quality SQL, we are checking to see if the employees table has rows in it. This is followed by an if block which tests to see if the variables which we populated using the SQL have values in them. In the first if block, we are testing to see if we have null department IDs in the employees table. And if it does, then the if condition will be true. It will enter the if block and create a debug log event which will say that we are in if block 1. This will be then followed by a warn log event which will say that the department ID is null. Now I want to remind you that this will occur only if there are null department IDs in the employees table and we enter the if block. In the second if block, we are testing to see if we have null employee IDs in the employees table. And if it does, the if condition will be true. It will enter the if block and create a debug log event which will say that we are in the if block 2. This will be followed by an error log event which will say that the employee primary key is null. Again, this will occur only if there are null employee IDs in the employees table, because of which we will enter the if block. The reason we used error in case if the employee primary key is null is because the primary key being null is a more severe error than department ID being null. So we should use the severity level that is appropriate to the data issue that we are dealing with. In the third if block, we are testing to see if we have rows in the employees table, and if it does not, the if condition will be true and it will enter the if block, create a debug log event which will say that we are in if block 3, and then this will be followed by a fatal log event which will say that the employees table is empty. Again, as always, do remember this will occur only if the employees table is empty and we enter the if block. Next, we create an information log event with the name of the stored procedure and a trace event to indicate that the program execution is complete. Let me go ahead and compile the stored procedure. The stored procedure has been successfully created. Before I execute the procedure, I need to enable logging. I will alter the procedure to set the log level to the lowest possible value, which is trace. As we discussed earlier, we do this so that all events which are of higher severity are logged in the event table. If I set the log level to info, trace and debug events will not be logged. So that is the reason why I am logging at trace level. We will also alter the procedure and set the trace level to always so that all procedure invocations are captured as trace events. Next, I will call the stored procedure and check the event table. The procedure has been successfully executed. Let me go ahead and select data from the events table. The events table is empty. It takes a few minutes for the events table to get data. As we wait for the data, let me explain why there is a delay in loading the table from Snowflake side. Writing to the events table consumes serverless credits, and writing a few rows of data is not very credit friendly. So Snowflake waits for some time in the hope that more events are being generated and would ideally like to combine them together and load the event table. This will result in credit saving. Now I will pause the video and come back in 10 minutes to see if the event table is populated. So I waited for about 10 minutes, and now let me go back and select data from the table and see if it is populated. As expected, we see a few rows in the event table. Let us try and find out if we can differentiate log events and trace events. The record type tells us if this is a log event or a trace event. If it is a log event, it will say log, and if it is a trace event, then it will say span. Before we jump in and analyze the data, it may be helpful if we try to understand what columns are present in the event table. Now, the thing about the event table is that the data populated in the columns will differ on some columns for log events and trace events. So we will start with the first column, which is the timestamp column. Now the timestamp column is populated for both log events and trace events. However, they mean different things for both of them. So let's try and understand that. For a log event, timestamp is the time when the event was created. Whereas for a trace event, it is when the trace event ended. So when we invoke a procedure, the procedure starts, which is the trace start time, and then the procedure ends, which is the trace event end time. So the end time of the trace is captured in the timestamp column. Now what you will observe is that the value for timestamp for a trace event is higher than the start timestamp as shown here. It is 611 here, and here it is 560. So the start time for the trace event was 560 and the end time is 611, which reflects the start time of the stored procedure and the end of it. Whereas in the case of log events, there is no start and end time, it just occurs, and that is why the start timestamp for a log event is empty. However, it is populated for the trace event because that is the start time of the trace event. The next column is the observed timestamp that we just spoke about. The observed timestamp is exactly same as the timestamp column and is null for trace events. The next column is trace. Trace column is not applicable for log events. However, for trace events, it basically captures the trace ID and the span ID. The next column is the resource column. The resource column is going to be blank for both log events as well as trace events. It is actually saved for future use. The next column we are going to talk about is resource attribute. The resource attribute provides information about the stored procedure which generated the log events and the trace events. Let us try and understand it better. I'm going to put it inside a JSON editor and let us review the most important fields. It has the DB user, the database name, the procedure name that I'm using, the executable type, procedure in this case, but if I used a UDF, it would be UDF, the owner name, the query ID, the schema name, the session ID, and the role that I used along with the warehouse. It also tells me the language, which in this case is SQL, but if I had used Python, then what would happen is that this would be Python, or if I use JavaScript, it would be JavaScript. So by looking into this column, I can identify all information regarding the procedure that was executed and collect all related information regarding that stored procedure. Now this value of resource attribute is same for trace events as well as log events. The next column we are going to be talking about is scope. Now scope is not applicable for trace events, however it is applicable for log events. Scope comes into place only when we create a class in a program like Python, And since we are not creating what is known as a class in this particular situation, the scope field is empty since our language is SQL. But if we had used Python and we had created classes in them, then in that case, for the log event, scope within which the event occurred, such as the name of the class, would be captured. The next field is scope attributes. Scope attributes is saved for future use for both log events as well as trace events. The next field is the record type. It is a field we already saw. It is basically going to be log for log event, and it is going to be span for trace event. This is what helps us differentiate between a log event and a trace event. You would basically write where record type equal to log to get log events and record type equal to span to get span events. Now the record field which you see here is basically the severity level recorded by the log event. Now you do remember that we used various severity levels when logging events, and those severity levels are basically captured here. The advantage of this field primarily is that you could come here, filter on a severity and look for logs that are of high severity so that you can figure out what went wrong with your procedure, or if you have a production issue, and troubleshoot it. In the case of trace, it basically says that it is a span where kind is equal to span kind internal. Now coming to record attributes is the line of the code in your stored procedure at which the log event was generated. And by using the code line number, you can actually go directly into your stored procedure and figure out where this event was generated. Now this is very helpful in case of those procedures that are very, very long. So let us say if you had a stored procedure that was 1000 lines long, knowing at which line the log event was generated will help you get to the source of the event very, very quickly. Now in the case of trace events, we do not have it primarily because we do not write any code to generate trace events. It gets generated when we invoke the stored procedure. Let's look at the value column next. The value column is the message that we provided inside our program. Now, if you look at the value, the severity level trace at code line number 10 maps to program has begun data quality, where the word data quality I passed in as a message. Next, I have severity level debug, and it says in the if block 1. So I know that I am inside the if block 1 because of the fact that there is a severity level debug, and I know that I have written the words in the if block 1 for the first if block. And then I get a warning message which says that the department ID is null. Now, there are several other messages that I had written, like error for primary key of the employees table. Those messages did not get logged, and the reason those messages did not get logged is because the if statement in those particular cases was not satisfied and the execution did not enter that block. So the log events will only get generated if it enters the if block and the log event is raised. Finally, I have the info message which is outside the if block. It says stored proc name is spdq employees, which captures the information log message I wanted to generate, and at the end I have severity level trace which says that the program has ended. The final column that we have is exemplar, and the exemplar is reserved for future use, and there is no data in this at this time. Now let me ask you a question. What would happen if I truncate the employees table and rerun the stored proc? Do you think the same log events would get generated again? The answer is no. If you truncate the employees table and rerun the stored procedure, what would happen is that the third if block would become true, and we would get the fatal error which would indicate that the employees table is empty. So depending upon the logic of the data, we will have different log events being generated, and we can take advantage of this to create log events to alert us of a particular situation. Now we can describe the events table. Let me go ahead and do that. All the columns we spoke about is present here along with its data type and a comment. Now the comment that is provided here is not very useful. So I will be providing you with a PDF document which you will find in the resources section, which will explain every column in detail, and it will also tell you whether it applies to log events or trace events. Event tables can grow to become very big very quickly. All the user-defined table functions and stored procedures in your account are using one table to log events. So you can expect a rapid exponential growth in the size of your table if everybody in your account is actually using the event table for logging. So there may be a need for you to actually reduce the data in the event table to manage storage and also to improve query retrieval. So what you could do is that you can delete the data from the event table based on a where clause, which would ideally be based on the timestamp column, where you can selectively delete data based on a schedule, which would be like delete all data that is over 90 days old on the first of every month, and thus you can control the growth of the data in the events table. Or you could also optionally truncate the events table if you want to. Now I'm not going to delete or truncate the event table now, but I want to let you know that we can definitely truncate the events table or delete the data based on a where clause selectively. Now another option is to switch to a new event table if your event table is becoming really big. So the way we can switch to a new event table is by using the alter account again. I have switched to a new event table. Going forward, all new events that are going to get generated will be logged to this new event table. Because this is a new event table, the size of this event table is not very big. A question that I get asked very frequently is, if I have multiple event tables, how do I figure out which event table is currently active? And the way we can do that is by doing show parameter like event table in account, and it will show you the active event table. Now I just switched to the event table TBL log events, which is why it is showing under value TBL log event. I can always switch back to the original events table if I want to. Events table support time travel. So if I want, I can go ahead and drop the events table. As you can see, I was able to successfully drop the events table. I can undrop the table by running the undrop statement, and by running the undrop, I am recovering the events table. So the events table, just like a regular permanent Snowflake table, supports time travel, and because of that it has time travel and fail-safe cost too. Event tables, just like permanent tables, can be clustered, and you can cluster the event table by using the cluster by clause. The reason that you would cluster an events table is primarily to improve performance. Now, if you are logging a lot of events and you want to improve performance, you can cluster by the record type, which splits the log events and the trace events. So let me go ahead and run this. So I was able to cluster the table successfully. If your event table becomes very big, you can help improve performance by adding search optimization. Now ideally you should create the search optimization on a column which is available for both log events and trace events, and since timestamp is a good candidate, I'm going to add search optimization to the timestamp field. So now I have added search optimization to the timestamp field. Every time I try to select data based on timestamp, which is something that I am highly likely to do in production, I will get my results back more quickly. I have the option to rename the table to a new name from the current name. Now I'm not going to do that, but I just want you to be aware that you can rename the events table just like you would rename a regular Snowflake table. So if for some reason you stop liking the name, you can go ahead and rename it. So I told you several times that logging consumes credits. So we need to have a way to turn logging off if we don't want to log it anymore. So the way we can turn off logging is by using the alter procedure name, and setting the log level to off. So I'm going to do that, and I'm going to set the log level to off. I can follow this by setting the trace level to off. Now if I go ahead and rerun the stored procedures, the log events and the trace events that were generated earlier are not going to be generated anymore. We can go to the information schema event tables to see the event tables that we have, just like how we did with the show events. We can also create streams on event tables, just like how we create streams on regular Snowflake tables. So in your production systems, if you are using event tables, explore the possibility of creating a stream on the event table to see if you can consume data in near real time and track fatal errors really quickly. Now, the question all managers want to know, what is the credit consumption for logging? And we can monitor credit consumption by going to account usage.event usage history. Out here, we have the start and the end times, the credits used, and the bytes ingested. And by basically summing up the credits used, you can get an idea on how much credits have been consumed because of logging. The important thing to remember is that logging should be used when needed. Logging should not always be enabled. The goal of logging is to figure out if something is not working and then to turn off that logging when we have figured out that things are working well. So it is important to keep logging at the appropriate level and turn it off when not needed. In the example we just discussed, we set the logging at the procedure level. However, we can set up logging at different levels. We can set up the logging at the schema level, or we could even set up the logging at the database level. Now, if you set up the logging at the schema level instead of the procedure level, all procedures inside that schema will start logging. If you set the logging at the database level, all stored procedures inside the database will start logging, and this can quickly lead to a lot of log events and trace events being generated. So you need to think carefully at what level you want to enable logging. You want to ideally enable logging at the level that generates the least amount of events and meets your business need. Now, similar to database schema and object, which in this case is the procedure, you can also set up logging at the account, user, or session level. Now, setting up logging at the account level will make no sense at all, because every procedure across every database in every schema will start logging. You could set up the logging at the user level, so whenever that user logs in, it will start generating log events and trace events. Or the other option is to use session. Now, the advantage of using session is that only in the session that you're working, it is going to actually generate log events. And as soon as you close the session, the logging is going to go away. Now, this is very good in the case of situations where you're trying to troubleshoot an issue, where as long as the session is active, you generate log events, you go to the log table, and what you do is that you use the messages that are generated to troubleshoot your issue. And once the session is over, you basically don't need to generate log events anymore. Limitations of event tables. In order to use event tables effectively, we need to understand its limitations. Event tables can be used for logging only when being used from inside a UDF, user-defined table function, or stored procedure. So, if you truncate or drop a table from Snowside, as we previously discussed, you cannot generate events for it. There is a lag of a few minutes before data from the log event or trace event is available in the event table. So, we need to be comfortable with the fact that the log event or trace event will not appear immediately. Event table structures are fixed and cannot be customized to meet specific use cases or logging requirements for your business. Adding an event to a table does not result in any action or resolution of the challenge or data issue you are facing. The events need to be analyzed, and manual action is needed in most cases to resolve issues. There is a 1 MB limit for log and trace event payloads. So, if the payload is over 1 MB threshold, the record in the event table will be incomplete. Costs of event tables. Businesses are sensitive to costs, and so let's talk about the costs of event tables. Serverless credits are needed to capture, log, and trace events to the events table. Event table credit costs can quickly escalate, especially if there is a lot of logging in your system. To help reduce costs, Snowflake collects the log messages and ingests them in batches into the events table. This is the reason why there is a delay between the generation of the events and the event showing up in the table. So essentially, this is a cost-saving measure. To reduce the cost of logging, we should avoid logging over long periods of time and enable logging only when needed. Logging can be done at different levels, so you want to make sure that you log at the level needed so that we do not generate more logs than necessary. Logging at the procedure level instead of database level, if our logging requirement is only for a specific procedure, will reduce events generated and the corresponding cost. Logging at session level to generate events only for a session rather than permanently setting it at the account, user, database, schema, or procedure level will reduce events generated and the corresponding cost. We should monitor credit usage by going to the account usage, event usage history, and check to understand credit consumption created by events. Similar to how regular Snowflake tables consume storage, storage cost for data in event tables will be charged to the account. So we should explore the possibility of removing data from the events table once the useful life of the event data is complete. Event table summary. An event table is a Snowflake table type which is designed to capture error messages or information messages generated by Snowflake automatically or generated by Snowflake provided logging functions used by a Snowflake data engineer in their code. Events can be captured when they are generated from a UDF, user-defined table function, or stored procedure. Snowflake supports two event types, log events and trace events. Log events, also called log entries, are generated by a Snowflake provided logging function used by a Snowflake data engineer in their code. Trace events are generated and stored inside event tables automatically by Snowflake to record the invocation of code like UDF, user-defined table function, and stored procedures. Event logging must be enabled to capture log events and trace events. The value of log level is set to off by default. Log level can take several values when enabled. They are trace, debug, info, warn, error, and fatal. Severity level of the messages increases from trace to fatal. Snowflake data engineer code can use system$log to log a message in the event table. If the log level is set to info, all system$log messages of equal or higher severity will be logged in the event table. The value of trace level is set to off by default. Trace level can take the following values when enabled: on event and always. When the trace level is set to on event, trace events are logged in the event table if the code has log events in them. When the trace level is set to always, trace events are logged in the event table every time the code is called or invoked, irrespective of if there are log events. There is a lag of few minutes before data from the log event or trace event. This is done to batch requests and save on credit consumption. Event table structures cannot be customized to add new columns to meet a specific use case for your business. There is a 1 MB limit for log and trace event payloads. If the payload is over 1 MB threshold, the record in the event table will be incomplete. To reduce cost of logging, avoid logging over long periods of time and enable logging only when it is needed. Log at the appropriate level needed to avoid unnecessary logging. Monitor credit usage by going to the account usage, event usage history.